Welcome to the project presentation for DAMG 6210, Spring 2025, Seattle. Team 1, please present your project.
Okay, so hi everyone, we're Team 1. Today we're going to talk about our database project. And as you can see, it's about a music recommendation. So these are our team members on our team. I'm Thomas, and we have Leo, Zoe, and Donglu. And this is our agenda. And I'll be talking about the business problem and ERD design. And after this part, we'll have data processing, reports, and future work. So to begin with, here's a problem that we have encountered in our daily life. That is, we have too many music to choose from. And sometimes it's difficult to find the music that we want to listen to. So we created the database to help solving this problem. And there's 3 objectives that we want to achieve with this database. The first one is the most important one. It's about personalized recommendation. We want to recommend each user with the best music that align well with their personal music taste. And the second thing we want to achieve is to involve users into our database. And we do so by allowing users to create playlists, and the database will use that function to generate recommendation to a user. And after that, the user can give feedback to those recommendations, and the feedbacks will help us to refine the recommendation algorithm. And that also takes us to the last point, which is behavioral patterns. We, as the database owner, we would like to study the behavioral pattern based on the user's listening history or their feedback on the recommendations. So here we'll talk about the business rules. The first one is about the user. We allow users to create account and store their basic information. And also we store the password as an encrypted data. And each user can create 0 or many playlists. And we solve the many-to-many relationship between playlist and song using an associated entity. So next, we use listening session and listening history to track the user activity. And each record will store the time and location data. And for each listening history, we'll have one user ID and one song ID as a composite primary key. So next, we'll take a look at our entity related to the song entity, which are the artist entity, album entity, and genre entity. As you can tell, the artist entity stores the artist name. Meanwhile, the album entity stores the album title and the artist who released the album. And the genre entity has a same relationship between song and between album, which is each song or album can have one genre, but each genre can belong to 0 or more songs or album. And besides genre, like most database would have, we created a mood tag entity to capture mood-related tags like energetic or peaceful. So we also resolve the many-to-many relationship using associated entity. So moving on, the next relationship is between the user and song again. The database will recommend 10 songs to the user, and the user can give feedbacks to the recommendations with a rating between 1 to 5. So with all that above, this is our final ERD. we have normalized the ERD to the third form to reduce redundancy and solve the many-to-many relationship by associated entities. And here's the tools that we have used to help us accomplish this. We use the Lucy chart to draw the ERD and use the SQL Server and dbeaver as the SQL tools that to help us interact with the database. So finally, here's the data set that we use to insert into our database. Next, my teammate Leo will talk about what we have done with the data set before we insert it into our database. Thank you.
Okay. Okay, next, I will expand how we integrate the data into our own schema for this project and how we turned raw data into a application and with a recommendation system. So our data set is from Kaggle. So we import the data into our database by labeling and processing the CSV file from the open Kaggle dataset. And it's published under the MIT license, which allows us to use it freely, including the commercial application requirement. And so we ensure the data integrity through several validation techniques at the database level. These include check constraint to validate the value range and nanu to enforce a required fields and unique constraints to avoid duplicates and proper use of normal data types like integer, decimal, or string. And in some cases, we also implement triggers and store procedures to handle more complex validation logic before inserting or updating records. So in the main part, how we built our recommendation system, we designed a blending and a weighting algorithm that allow our recommendation systems to integrate multiple data source. In our case, is a part of its user specific the listening history, and another side is the overall trend. So this procedure use two decimal parameters to control the influence of each source. So if we put 0.7, it means 70% output sources, and allow us to dynamically adjust the weighting based on different needs. So we can fine-tune our algorithm by changing this number. So our current strategy combines user listening history with overall popularity rankings. We implement the procedure to allow us to extend it with target-based logic and the batch update feature to refresh all the users' recommendation efficiently. So this algorithm is deployed direct within the database, which is very helpful to improve the performance because it's very low data transition. So when we handle a large volume of data, can be used a little bit performance. So this design also able to easily fine-tune as I mentioned before. So the algorithm composition and a CI/CD deploy task will be more easily. So we also utilize several SQL features to maintain the integrity and the reliability of our database. By using check constraint, we ensure the data remains valid and consistent. So in our case, our recommendation system will have our interface is maybe like a front end or a mobile, whatever, but we use the check constraint to protect our data in our database. And another case is like computed columns. To optimize the performance by delivering the useful values from existing data. Like we calculated the user's full age based on their birth date, and we generate the display name by combining the information from different table like song and albums table. And lastly, we implement the data encryption to ensure the sensitive information is not stored in plain text. That reduce the internal security risks and can protect our private user data as well. And next, Zoe will talk about the visualization of our project.
Thanks, Leo. So before I dip into our data visualization, let's take a glance of the data set, the data in our data set. We've built our data set using 15 users covering the period from January the 1st, 2024 to April 5th, 2025. During this time, we provided over 6,300 songs and around 4,700 artists for users to explore, result in approximately 20K user history records in our database. Looking at our records, the most popular picks among our users are Face for the Radio/Voice for a Silent Film Deluxe, Organic Passion, Detroit, After Party, Batch and Friends, and K-pop. These selections reveal a wide variety of musical taste, from Indian vibes and energetic modern tunes and to innovative classic fusion. We've also analyzed our popular artists. I won't repeat every names. Recently, I think people tend to choose very unique and weird names, which is made it's hard to pronounce it. So, but we can see the diversity is truly impressive. Next, let's review the sound mood distributions. Let me introduce what is the mood tag. So for each song, based on its content and name, we would assign a mood tag to it. For example, if a song named Feeling Good, we would assign happy tag rather than the dark tag to it. The distribution graph shows that most users, they prefer cheerful, energetic, and romantic songs. In terms of genres, our top 10 list includes industrial, drum and bass, world music, J-pop, and deep house. They are all well loved by our listeners. So these insights not only highlight our users' diverse musical preference, but also provide valuable guidance for enhancing our future song selections. Now, let's switch our attention to the user time report. This chart shows total engagement hours per user. As we can see, the user 11 tops with 247 hours, while the user 13 only spent about 200 hours in listening to the music. The overall average time is actually not that bad. It is 226.7 hours. So this data helps us identify the power users and also target the strategies to boost engagement among less active users. We've also developed a Tableau dashboard for user-specific reporting. This is a screenshot of the dashboard. Here I'm going to do a little bit demonstration. So I'm sorry, the PowerPoint doesn't compile with the Tableau dashboard pretty well, and the as-in doesn't work pretty good. So for example, if you pick, as you can see, if you pick a user 1, it will populate your top 5 favorite artists albums and your top 5 favorite songs and genres based on your listening histories. For example, and then let's switch to user 8. As you can see, he loves to listen to the songs which is called road trips. He listened 10 times. So when we recommend the songs for him, we might look into the songs that are related to road trips. And okay, sorry. Last is our recommendation analysis. As you can see in the bar chart, ratings of 1, 4, 5 stand out. And we've actually noticed that fewer than 20% of our users gives the highest ratings of 5 to our recommendations. This is sad, but this is also indicating that there's a room to improve our recommendation algorithm. Maybe it was too simple or not right. Our goal will be to refine the system so more users experience highly relevant song suggestions. Now, I'll pass it to Dong to talk about what we've learned and the future work.
Okay, thanks, Zoe. So first of all, we learned, thanks to professor and throughout this project and this semester study, we've gained hands-on experience in, database design principles. We learned how to normalize table and define relationships like one-to-many and many-to-many relationships. And we also learned how to write complex SQL queries, joins, and constraints. We also did data visualizations. We transformed the raw data into insightful visual diagrams, like Zoe demoed. And most importantly, we also got data thinking, like understand how to construct and process data to drive decisions. Next page, please. And for the future development of our project, our database, basically we outlined 3 main directions. Firstly, we plan to integrate a machine learning-based recommendation model. And secondly, we plan to develop a more interactive web-based dashboard. And finally, we want to enhance our tagging system to refine the recommendation accuracy. Next page. Okay. In terms of the recommendation models, we plan to implement either collaborating filter or content-based filtering to provide the user with personalized suggestions. We also want to incorporate user feedback to fine-tune our model. Next page. And the next, although we already have a very simple Tableau dashboard, we still plan to create a more interactive dashboard to allow users to visualize more content like listening history, playlists, and personalized recommendations. And this dashboard will support user login and real-time updates, making the experience more engaging. Next page, please. Next, okay. Our third direction is to enhance the current tagging system by incorporating more advanced tags. These tags will be based on lyrics, melody, rhythm, and instrumentation. This will allow users to have a richer understanding of the content. And this system will support multiple dimensional tagging to improve the quality of our recommendations. And lastly, the system will support both automatically generating and user customized tags. User will be allowed to add tags for songs, artists, and albums. Next page. So what's next? How to achieve our goals? Let's take 72 and 75. Yeah, that's all. Is there any question about our project? Do you have any questions? Recommendations?
Okay, I'm Soyungang from Team 4. You guys had a great job. Yeah, good job. And you have mentioned about some mood tag. You have assigned mood tag to each song. So will each song have multiple tags or a single tags, or how it works on the tags?
Thank you. Thank you for your question. Yes, so each song will, in our ERD, each song will actually get multiple mood tags. For example, the song could be cheerful and happy as well. But in our database, when we importing the data, to simplify our process and reduce the complexity, we actually only assign only one tag to each song. But that doesn't mean that each song will only get one tag. By default, it should have multiple tags. Thank you.
Thank you.
Hello everyone, I'm Ashish from Team 4. I had a question regarding the improvements slide that you guys said. So you guys spoke about how you can improve your model. Is there any specific idea to improve the recommendation algorithm?
Well, as you can see, the recommendations, the feedback wasn't that good. Our algorithm was quite simple. So as Lu Dong mentioned, we will definitely incorporate like AI tools in the future. So for example, with those top 5 songs that a user listened, each of them have a mood tag and they have like the album. So in the future, we might incorporate this factor into our algorithm selections. For example, if you listen the song, if your top 5 song is a song A in this album, and I hope our algorithm in the future will include like the other songs in the album to the users. And also, we didn't mention we in our database there is also a time. So we hope in the future we can categorize the time. For example, this user, he always listen to like cheerful songs while he is during the work commute. So we can categorize this, and in the future we will provide more cheerful sounds if we can detect that the user right now is driving to work. So these are some ideas we have right now, but yeah, hopefully we will eventually achieve this.
Yeah, that makes sense. Thank you so much.
Thank you. Any questions?
Do you have any other question or comment for Team 1? So Team 1, your work was very impressive, and your data analysis was outstanding, and I think your team had a very good sense about data work, and I really like your future work or future improvements to the project, especially the integration between AI, machine learning models, and the database data. I think that's very interesting. Perhaps we could create some new tables or additional fields, or even a downstream reporting database or data warehouse to facilitate the integration between AI models or data mining solutions. I think overall your project was very, very good, very impressive. Thank you for the great work, and thank you for the question.
Thank you, Professor.
Yeah, of course. Great work and great presentation. Thank you again. Thank you for the question from Team 4. Any other question or comment for Team 1? Okay, let's welcome Team 2.
Hi, Professor. Can you see my screen right now?
Yeah, you are on. Go ahead, please.
Yeah. So hello everyone, we are Team 2, and today we are presenting our final database project, the library management system for Northeastern University. So we designed a relational database to support the operations of an online library, enabling students and staff to efficiently search, borrow, return, and manage books. Our system also manages inventories, reservations, reviews, and fines in a structured and automated way. And our system covers all essential functionalities of a modern library, book inventory and copy availability tracking, member feedback and book review capabilities, borrow and return workflows using constraints and triggers, and also we monitoring of member activity, fines and payments, blocking new reservations if fines are unpaid via UDF and check constraint. For reservation queue handling with automatic status transition, we can transit from waiting status to available status and the fulfill status. And we can also set the reservation as canceled. And SQL-based reporting and Tableau power visualizations, and we also enable password security through encryption using AES 256. And here's our ERD, which includes more than 12 entities. Key components include book, category, author, copy, member, borrow record, fine payments, reservations, and book review. We ensured the design is normalized to 3NF. Each book must belong to one category, and each book may have multiple authors, modeled through a book author bridge table to support many-to-many relationships. And a book can have multiple copies, each tracked individually through the copy table with a real-time copy status like available or borrowed. And members can borrow books, which create a borrow record. Each record tracks which copy was borrowed and whenever it has been returned, and if a borrowed book is overdue or damaged, a fine will be generated and linked to its specific borrow record. Fines can then be fully paid through the fine payments table. And members can also reserve books that are currently unavailable. If all copies are borrowed from somebody else, we can make some reservations, and the reservation status are tracking as waiting, available, fulfilled, or canceled. And we also enforce some rules such as only active members can reserve or borrow new books, and one copy cannot be borrowed by more than one person at the same time, and member must pay their unpaid fines before they can book their new reservations or borrow record. And finally, members can leave some book reviews linking the member and book table with the feedback and the rating. We also implemented SQL table level check constraints to enforce business rules. For example, a custom function member unpaid fine ensures a member cannot make a new reservation if they have unpaid fines. And let's look at our first trigger at the left side. It prevents double booking of the same copy. If a user tries to borrow a copy that have been already borrowed and not yet returned, the trigger will block the transaction and raise an error. We think this will help keep our borrowing record clean and avoid conflicts. And at the right side, this trigger validates reservation requests before they are inserted into the system. Whether the member is active, it checks whether the member is active. And if there are already available copies of the book, we can make a reservation. If we have available copies, then make a reservation would be unnecessary. Only if both those conditions are met, the reservation will be accepted, and it provides redundancy. And our trigger also automates system behavior. Let's take a look at the left picture. The trigger function updates the status after a new book record. When a book copies is borrowed, the copy status should be set to borrowed, and the earliest available reservation is automatically marked as fulfilled. This helps synchronize book status and reservation queue without any manual updates from the administrators. And when a book is returned, another trigger updates the status to available, and it also finds the next waiting reservation for that book and updates the status to available. And together, these triggers automate circulation and keep the system responsive. And next is field views. On the left, we have the member reserved books view. This aggregates all books reserved by each member into a single horizontal field using the 4XML pass technique. It gives a clear view of each member's reservation history. And on the right, we have the top 5 readers. It ranks members based on their total number of borrowed book using a combination of aggregation and ordering. This helps librarians and quickly identify the most engaged readers in the system. And another helpful view is the book available copy IDs. This view shows each book's title along with all of its currently available copy IDs and displayed horizontally in a single string. It also includes the total number of copies for each book, both borrowed and available. And we use the STIF and 4XML pass techniques to display the available copy IDs, making it easily for members to quickly see which copies they can be borrowed. And next, Peiyu and Mei-Ling will introduce the views and the visualization part.
Hi everyone, I'm Mei-Ling. In this part, I will go over the remaining views we created, show how we encrypted user password, and explain the computed columns we added to a member table to help track activity. In this slide, the top section is our book popularity rank view. It displays books ranked by the number of times they have been borrowed. For example, database system concepts has been borrowed 17 times and is ranked number 1 in popularity. We used a dense ranking strategy, meaning books with the same borrow count share the same rank. This allows library staff to quickly identify which books are in high demand across various categories like technology, biography, and business. The bottom part is a reservation queue view. This view helps track active reservations and displays each member's position in the queue for a particular book. For instance, Benjamin is first in line to borrow the Poor of No, where Ella Foster is second. This view dynamically reflects real-time queue positions as books are returned and the reservations are fulfilled or cancelled or handled automatically through our triggers. It improves transparency for library staff and makes secure management more efficient. Next, please. This view, book available copy IDs, provides a quick snapshot of each book's availability status. It serves two purposes. First, the available copies listing. For each book, we listed the available copy IDs into a single horizontal string. This makes it much easier to read and understand which specific copies are currently available without needing to scan multiple rows. Second, the total copies account. It also shows the total number of copies owned by the library for that book, regardless of where they are borrowed or not. We used the staff and full-time pass technique in SQL Server to transfer multiple rows into a horizontal comma separated string. Finally, we filled out any books that has 0 copies in a library, and so only relevant data is shown. Next, please. In this slide, we are showing how to keep user passwords saved in a Microsoft SQL Server database by using encryption. We started by creating a master key, which is protected by a strong password. This is needed for all the encryption work. Next, we set up a certificate, which helps us create and manage a symmetric key using AES 256 algorithm, which is one of the most secure options out there. Once the key is ready, we open it with a certificate so we can start encrypting the data. As we can see in the screenshot below, we have used this method to encrypt some of the passwords in a member table. The encrypted results look like random characters and can't be read unless you have a red key to decrypt them. This shows how encryption helps protect sensitive information and makes sure we are following best practices for data security. Next, please. This slide shows how we extended the member table by adding 4 computed columns using functions. And these columns help us automatically calculate important information for each member. The first column, borrowed this year, counts how many books a member has borrowed in the current year. The second column, unreturned books, tracks how many books the member hasn't yet returned. The third one is active member, is a flag that tracks whether a member is active. In this case, someone who has borrowed at least 5 books this year. And finally, total fine sums up all the fines that the member has accumulated by joining the fine records with the borrow history. These computed columns make it easier to analyze member activity and borrowing behavior directly from a member table without needing to write complex queries each time. Next, Pei will introduce the visualization part. Thank you.
Hi everyone, I'm Pei Yu. I will walk you through our report. The first part is book analysis. In total, we have 320 books in our dataset. The earliest publication date goes all the way back to 1936, and the latest one is 2020. So our collection spans more than 8 decades, giving us a rich historical perspective. And now let's look at the category breakdown on the left. As you can see, technology dominates the collection with 125 books, which is about 38% of the total. This shows a clear emphasis on technology in our library. So overall, the collection is strongly focused on technology and literature, while categories like art and philosophy are less represented. And moving to the right, let's examine the book ratings. Most of our books are very well received. Books rated 5 stars make up the majority with over half the collection. And 4-star books follow at around 22%, showing a solid reader satisfaction. And lower ratings, such as 3 stars and below, are relatively few, indicating our strong quality control in our selections. And next, let's look at our borrowing record distribution. To begin with, we have a total of 101 members in our library system, and they have collectively made 915 borrowing records. This gives us a good understanding of the library's members' engagement level. And let's look at the pie chart in the left bottom, which shows the membership distribution by join date. Members who joined in 2023 comes from the largest segment, accounting for about 33% of the total, and members from 2022 represents 23% approximately. And finally, the newest members from 2025 contribute a smaller proportion so far, as expected since this year has just started. So this indicates that we have a relatively steady membership growth over the past few years, which 2023 is particularly strong in terms of our new member registrations. So if we click, say, on the yellow part of the pie chart, we will get a focused view. On the right side, we have 34 members who have contributed to 303 borrow records. This is likely based on the active members on this recent borrowing activity. So next, let's move on to the trend analysis shown in this line chart. So this chart displays the monthly trend of our borrowing records. And we can see that we have two spikes concentrated on from May to August, both on 2023 and 2024. And we also have after this peak, we also see some fluctuations. It covers towards the end of 2024, indicating a sustained interest. So this drop could be due to some seasonal factors, completion of specific programs, or we can do some more investigations in the future. And next, this is the book popularity analysis, which represents the counts of borrow records of individual books, and they are also categorized. So the horizontal axis shows the count, and the vertical axis lists the book titles along with their authors. So each bar is colored by their category. So blue for technology, brown for businesses, and orange for science. And right away, we can see that at the very top, the most popular book is Database Systems Concepts, and indicating that this is our most referenced book. And this pattern also shows a strong reader demand for technical and programming related content. And midway down the chart, we can also see a shift toward a broader mix of categories, such as biography and businesses and science. So this suggests that while technology dominates, other categories are still receiving attention, providing some diversity in the reader's interests. So yeah, so let's continue to the next page. Yeah, so if we click on a specific category, let's say the science one, it will highlight all the books belonging to the science category. So this feature will help us quickly focus on one category at a time, making it easier to analyze trends and compare within that specific group. Yeah, and next, let's take a look at the book category trends by year. We can see that all categories share a very similar trend. They all spike until the mid of 2024. Yeah, and next, let's take a look at the top 10 books by average rating. So first, we can see that most books have received a 5-star rating. Yeah, and next, yeah, let's take a look at the top 10 members. This chart represents the top 10 members ranked by their total borrow count. We can see that the most borrowed member is on the right, and it has around 22 borrowing records, and the others have generally between 17 to 22 borrowings. So this suggests a healthy level of engagement across multiple members. So this insight will help us better understanding our most active users and could guide us in future engagement strategies. Yeah, and next, let's look at this review analysis. So we have 310 reviews in total collected from January 2022 to February 2025. And on the left, the donor chart shows that this distribution of categories. We can see that technology still leads a large margin, contributing to 39% of all reviews. And other categories like philosophy, history have a smaller but still notable shares. And on the right side, the pie chart confirms a very similar pattern. Technology also, again, dominates and holding a 38% of the total reviews. And other categories maintain lower proportions, indicating areas of potential growth. So next, if we click on the technology category, we can have a focused view. So this view isolates the technology reviews, giving us a perspective on this dominant category. It will help us understand the depth of engagement within this category while reviewing gaps in other categories. Yeah, and next. Yeah, this is very similar. This is when you click on the fiction category, it contributes to a relatively small segment with 33 reviews in total. And while the overall volume is smaller, this perspective also helps us highlight the trends and potential growth. So if a certain category has a large inventory but receives relatively few reviews, it might indicate that a potential issue with our selection strategy for that category. So maybe the books are not appealing enough to readers, or they are not well matched with our audience's interests. Yeah. So that's the end of our presentation. Thank you. Does anyone has any questions?
Okay. I'm Leo from Team One, and I would like to know what do you think to need to be improved for this design of functionality of the database?
I think if we have more time, what we like to do in the future is maybe update a new overdue fine system. So right now we don't have a fixed return deadline for our borrow record. Because the return expectations may vary by each members, they could set for themselves. And we only provide a borrow date and a return date. If the member did not return the copy, the return date should set to null, but we don't have an expected return date that's set by library. And I think in the future, we could add an attribute called expected return date into the borrow record table. And we could implement a more dynamic system. For example, if a book is not returned by the deadline, the system could automatically send a notification to the member and ask them to return, and then a fine would be inserted into the fine table. And if the book remains unreturned after a certain period, like a month or so, the system could just escalate the penalty by increasing the fine amount. maybe by an additional 20%. And we could also integrate a notification system that alerts member via email when the reserved book become available. So they could mark the reservation as fulfilled and create a new borrow record. And the system could also notify the member when their due date is approaching or any books are overdue and alert them to pay their fines. I just thought this would make the system more automated and more like a real-world library. Yeah.
Okay, I see. Thank you. And I like the visualization part. Great job.
Actually, I have one more question. And so how did you create or design the data for the library in your project?
Yeah, thank you for your questions. As for the data part, I used a data set downloaded from Kaggle, which originally has about 3 million data as the base for our library information, such as books, authors, and ratings and reviews data. So, and as for the borrowed record data, I wrote a custom script to generate it according to our specific requirements. For example, I control the fields such as borrow dates and member IDs to simulate realistic borrowing patterns across multiple years. Yeah. So I think this approach can ensure the data consistency and cover different borrowing scenarios for a better analysis. Yeah. Thank you.
Okay, I see. Thank you for your answer. Thank you.
Thank you.
Great work from Team 2. Team 2, I have a question. So once you downloaded your source data from internet and you did some, you created scripts to do pre-processing, what scripts did you use?
I wrote a Python script.
Okay,
to
that's what I
generate.
thought. Okay, yeah, great work. So your team did a lot on the project. Your data analysis, reports, and visualizations were pretty thorough and pretty impressive. Great work and a great presentation. Thank you, Team 2.
Thank you, Professor.
Yeah, and thank you for the questions from Team 1. Let's welcome Team 3.
All right. Can you see my screen here?
Yeah, you are on. Go ahead, please.
Okay. So, hello everyone, and we are Team 3. Thank you for joining us together to going through our final project. This is a Target-like e-commerce database management system, so we call it Target version 2. Our team members Yang Zheng, Meng Yunxie, and Chenny Xu designed this system to address the needs of modern online retail operations using a robust, scalable, and secure relational database structure. So then let me highlight a high-level overall of our database system. The goal of this system is to support the entire online retail experience by providing a solid and scalable backend structure from customer accounts and product listings to order processing and customer service. Some of our primary goals include improving the efficiency of shopping operations, ensuring smooth order processing, and providing both customers and administrators with a seamless experience. Our system supports important e-commerce features such as detailed customer profiles with address management, shopping carts, and order history, as well as coupon handling and customer reviews. With these features, Target version 2 lays the foundation for a reliable and user-centric e-commerce platform that can grow with business needs. So to structure our system, we defined 4 main objective areas that reflect essential business functions in e-commerce. First is customer and account management. This module is responsible for storing customer profiles, including personal details, saved addresses, and multiple payment methods. It enables secure and personalized shopping. Second one is product and inventory. Products are organized into categories and subcategories, with each variation checked at the item level. We monitor stock quantities in real time to ensure accurate availability. And the third one is ordering and promotion system. This covers the complete purchasing process from shopping cart to final order. We also support coupon-based promotions that can be applied to individual products, helping businesses increase engagement. Finally, we have customer interaction. To support ongoing customer engagement, we added modules for submitting product reviews and raising customer support tickets. This ensures users can provide feedback and resolve issues efficiently. These objectives guided our ERD design and the development of our SQL scripts. So now let me go through detailedly of our ERD. This design consists of over 20 interconnected entities. The ERD captures all essential components of an e-commerce system, ensuring efficient data organization and operational clarity. First, of customer and account management objective, we have customer entity to store user profile details, and also customer address, and country entities to support multiple saved addresses per user. And the payment method and payment type entities checks customer payment options. Then for the product and inventory objective, we have product and category entities to organize items into categories and subcategories, and also the product entity to store the product details like price, SKU, etc. And for the ordering and promotion, we have the shopping cart and shopping cart item entities to allow user to select items, and the shop order and order line to capture finalized order details. Also, the order status and shipping method check status and delivery method. The coupon and coupon category entities allows us to apply targeted discounts to items. So the review entities give feedback linked to specific order items, and along with the customer support ticket and ticket status entities to issue reporting and resolution checking. So this ERD ensures strong referential integrity through primary key to foreign key relationships, support for one-to-many and many-to-many associations, reusability and extensibility for future system growth. Then we will have our teammate Meng Yun to introduce the database implementation.
Thank you, Chen-Yi. Hi, everyone. I will walk you through the implementation part of our database. We have organized everything into SQL scripts, cover table, definitions, computed columns, encryptions, constraints, procedures, triggers, DML, and some useful views. Let's take a closer look at each of these. Next. Next, please.
Can you see?
Oh, yes.
I already added the
Oh,
DDL script.
Yeah, here is our database schema implementation. We have created 20 tables to support our e-commerce system based on the ERD we showed earlier. The schema includes everything needed to manage our core business functions. As you can see in the screenshot, we got customer address, country, and so on. Each table includes primary keys, foreign keys, and other constraints to maintain referential integrity and enforce business rules. Next, please. In compute column SQL, we've implement 7 reusable functions to support dynamic data generation and reporting. Get customer phone name combines a customer's first and last name. Get customer format address formats a customer's default address cleanly. Get total stock helps us track inventory and categorize product availability. Get stock status, look at product stock and return in stock, low stock, or out of stock based on the quantity. And get top 5 best sellers, rank our top selling products dynamically. Get order grand total, calculate the final cost of an order with coupon discount. Get unsolved tickets, list all customer support tickets that are still open or in progress so we can tackle them as soon as possible. Next, please. Here is our column data encryption SQL. As we know, security is a critical concern for any e-commerce system. This script focuses on the data privacy and security. We apply encryption at the column level for the sensitive field like password to protect customers' privacy. Next, please. Now let's talk about table level track constraints SQL. To maintain data quality, we use two validation function as track constraints. The isValid email function ensures all email address in our systems follow proper formatting rules. The isValid phone number function supports both international and North American formats. These constraints help prevent invalid data from entering the system. Next, please. Moving on to the stored procedures SQL, we've created 3 critical stored procedures: insert order line, delete order line, and insert shop order. These procedures simplify tasks like adding items to an order, removing them, or creating a new order, all with proper validation. But to understand why they are so important, let's first explore what would happen without them. Now imagine we didn't have stored procedures. Every time we insert data into the order line table, we'd need to manually track a related table like shop order, product item, or coupon. This leads to repeated actions and more room for errors and potential security risks. And with stored procedures, we simplify everything. Take insert order line, for example. It handles if order line ID is none, we generate a new one. Check that the order ID exists in the shop order table, and then check that the product item ID exists in the product item table. Check that the coupon ID exists in the coupon table if provided. Check if there is enough stock. Then we will insert into order line and update the product stock quantity. This is exactly what delete order line and insert order shop order do as well. We keep our business logical, consistent, secure, and efficient. Next. Here is our trigger sequence. We define two key triggers. The outline calculates price trigger automatically calculates the correct price whenever items are added or updated to an order. The outline delete trigger ensure order totals remain accurate when items are removed. These triggers ensure our order date stays accurate without require extra manual work. Next, please. Here's our DMRO SQL handles data manipulation. We have created a comprehensive data for each table, ensure more than 10 rows per table. And now let's welcome my team member Yang Zheng to continue.
Thank you for Mengyun. And after we build the entire database and insert our data on it, we create several views to help the target teams perform better product and customer analysis. The first view is about the customer purchase histories. In these views, you can see that the customer ID, its name, its email, and its basic informations. And also you can see the order ID, order data, order status, for that order line, and the product SKU and the quantities about this product. And we also recalculate unit price and give you the line total for a reference. And this table could help customer service to quickly view a customer's complete purchase histories. And for next views, we build a product sales performance views. In these views, you can see the product ID and its names, category names, and these informations. And you can see the number of orders which have this product, and the total quantity already sold it about for this product. And we also calculated the revenue for this product and the average rating and numbers of reviews related to this product. For these views, we think the last one. For these views, we think that the marketing and product teams could use it to identify the top performing products, and they can also use to analyze the sales margins and make some decisions about inventories or something else. So we think that could be really helpful for the product teams and the marketing teams. For next views, we build a product inventory sales status views. In these views, you can also see the product name, ID name, and the SKU and its current inventory. But we use some calculations to get the quantity sold in this month and quantity sold in this year for this product. This is very helpful for the inventory tracking and also helpful for the product teams to make some sales analysis and to help them to make the restock decisions. And for the next views, we build order fulfillment status views. In these views, you can see each order, its order ID, its order date, and the customer name who made this order, and the order status in the current stage, and the shipping address, and the total items, and we also calculate to get the order value, and we also get the days since order, and we think that this provides a complete picture of the order that which need to be processed, to be packed, and to be shipped. This will also could help the shipping teams to manage the order fulfillment prioritize. And for the next views, we build a customer support dashboard. As we all know that the customers may have some tickets need the customer support teams to handle it. So in these views, you can see each ticket's ID and when it's created and the status and the customers who related to this ticket and the customer's basic information such as his name, email, and the phone number. And you can also see the order ID related to this ticket and the product name related to it and the issue descriptions and how many hours it had already opened. This could provides very helpful context about customers and their issues. Could help the customer support team to streamline the support process. And after that, we build another views about the secure payment information. We all know that the customer service, they need to see some payment methods to help customers, but they shouldn't have access to the complete account numbers. So we build these views that could be used for the customer service teams. They can see the payment method ID, the customer's ID, the payment type ID, the providers, but for the account numbers, they could only see the last 4 digits. Yeah, this is for security reason, and this could mask the sensitive information while providing the necessary context for them. And after we build all these views, we use the table to create some data visualization charts, which could help the target team to gain a deeper and more intuitive understanding of all the data and to help them to make better decisions. We have built the 6 dashboard. And for the first dashboard, this is the coupon discount impact dashboard. For the next page. In this dashboard, you can see that all the coupons and some of the order line ID are in the left chart. We can see that based on all the data we imported, and the most order lines, they didn't use any coupons. But using this chart, we can see that which coupons is most popular and always used by the customers. And for the right chart, we can see the revenue impact from these coupons. The part above is about revenue without coupon, and the part below is the revenue with coupon. And we can see that before the August 2024, they have the totally opposite trends. But after the August 2024, they have the similar trends about the revenue with coupon and revenue without coupon. And for the next dashboard, we built a customer insight dashboard. In this dashboard, you can see that the customers, their registration date and the distinct of the customer ID in each month. And you can see that in which months that customers, you have most new customers. And you can also see the customer distributions by countries using this map. I think that's very cool. And after that, you can also see the lifetime value per customers. You can see that the Arden Parker, he is our most, he is a huge fan of the target. Yeah, and you can also see the customer repeat types. How many customers they only buy once, and how many customers they are the repeater buyers. And then we built another dashboard about the customer support dashboard. Using this dashboard is always about the tickets customers created. You can see all the status of all the ticket status and how many tickets in that status. And you can also, according to the tickets informations, you can get the complaint categories. Maybe some people complain about the damaged products or the delivery delays or something else, and this could help you to know what customers they are focused on and to help them to solve their problem. And we also built a chart that you can see the tickets created per week. And for the next dashboard, we can see this is the inventory dashboard. For each product, you can see the current inventory and the quantity sold per product. And you can see that the Welfare L-shaped desk and the Sony Alpha A75 for these 2 products is the most popular product in the target. And then for the next dashboard, we built a product rating dashboard. As we have the rating 1 to 5, so you can see that each rating in each rating how many products it this rating. And for the rating 5, and the good news is most products they get the rating 5, and some get rating 3 and rating 4. But also a very good thing is none of product that they get rating 2 or rating 1. Yeah. And you can also see the review count over time and the average rating by product. And for that, you can check each product's average rating and to decide whether it's popular or not popular, to decide your restock decisions. Okay, and for the last one is a sales dashboard. In this dashboard, you can see the top selling products, and you can also see the revenue over time. And we build this chart using the every month's data. And you can also see the sales by category and to make some analysis about which categories are more popular. Yeah, and this is all the Tableau dashboard we have built it. And this target version 2 e-commerce management systems really represents a comprehensive and innovative solution that redefines the online shopping experience, empowering the business to build trust, streamline operations, and drive growth in the digital retail landscape. And thank you for all. That is our representation. Anyone has any problem?
Hi, I'm Manu from team 4. I think it's a great work and very comprehensive. I'm wondering what's the specific data did you encrypt and why? Thank you.
Hi, thank you for asking. Please help me move to the detail slide. Yeah, yes. As we can see in this slide, there's a customer table. We encrypt customer password, and the reason why we chose to encrypt this specific data is because first, we think passwords are highly sensitive and must be protected from unauthorized access. And if a hacker got a plain password, they can break into users' accounts. Also, many people use the same password on different websites, so leaking one could affect them all. So to address this risk, we use SQL servers, built-in encryption tools, master key, certificate, and symmetric key to securely store passwords and protect our system. Does that answer your question?
Yeah, makes sense. Thank you for your answer.
Thank you.
Hey, this is Pei from Team 2. I really like your database design and ideas, and I'm curious to learn more about your implementation. Could you please explain how your triggers help ensure your data consistency? Thank you.
Oh, thank you so much. I think it's a very good questions. Please help me. Oh, yeah, that's our trigger. We can see here there's 2 triggers in our system. We designed these triggers to automatically maintain data consistency across related tables. So there's no need for manual recalculates. For example, the order line calculate price. This trigger runs after an insert or update on an order line table. It calculates the line item's price use the product's base price, quantity, and any discount. Then it updates the corresponding order total in the shop order table by summing all line items and adding the shipping cost. And for the second trigger, the order line delete. This trigger runs after a delete from the order line table. It recalculates the shop order total to reflect the delete items, keeping the total accurate at all times. So these triggers ensure the date stays consistent even when users add, update, or delete all the items. Yeah, that's our design.
Yeah, thank you.
Thank you.
Your answer really helped me more clear about your implementation. Thank you.
Thank you. So is there any questions?
Team 3, you did a lot on your project and your implementation was very complete, thorough, and solid. You developed a lot of SQL Server-side modules to implement and enforce your business requirements. You also created a lot of views, and the views were used in data analysis for creating reports and visualizations. Overall, your project and presentation were very solid and very impressive. Thank you for the great work, and thank you for the great questions.
Thank
you, Professor. Thank you, Professor.
Yeah, of course. Last but not the least, let's welcome Team 4.
Hi everyone. Our team's project is about a health and fitness management system. It is a comprehensive platform integrating all aspects of our wellness journey. Our team members are Xiaoyang, Ashish, Isaac, Mohit, and me. And next slide, please. And this is our content. First, I will make a comprehensive introduction of our motivation to do this database. Second, Ashish will introduce our business requirements and rules. And then Xiaoyang will take a deep look at our ERD and database implementation. Finally, Isaac and Mohit will show our final virtualization and daemon. In recent years, there has been a huge shift in how people think about health and fitness. More and more individuals are trying to eat healthier, stay active, and maintain good habits. But here's the problem. Most of the applications or tools available today only focus on one piece of the puzzle. Here are some limitations we found for a current health system. They have no admin report, some scheduling challenges, poor targeting, or missing engagement. Some applications let you track meals, and some others focus only on workouts, and a few offer expert advice, but rarely do they all work together in a simple platform. And next slide, please. So our motivation behind this project was to fix that. We want to build a centralized all-in-one system where users can do everything. The health and fitness management system is designed to support individuals in managing their fitness journey by providing a unified platform that tracks meals, workouts, appointments with experts, and health progress over time. It brings together all elements essential for achieving health goals in one cohesive and user-friendly application. Our system designed to accomplish functions like you can include log what they eat, can track their workout, and can get reminders from healthy habits, and can schedule appointments with trainers or nutritionists, and can see how they are progressing over time, like calorie burn or even sleep quality. In short, we're aiming to make health management simpler, smarter and more personalized for users by bringing everything together in one place. Next. Besides that, now let's take a closer look at our system. The system's requirements revolve around building a comprehensive database that caters to all touchpoints of a user's health journey. Each user needs to maintain a profile that includes their current weight, target BMI, daily calories goals, etc. Users can also log their meals and physical activities, which are stored with time-specific data. The system allows for scheduling appointments with staff, such as trainers or nutritionists for personalized guidance. Additionally, features like progress report, reminders, and reward system are incorporated to maintain consistency. So that's finish of my part. Now let's welcome Ashish to introduce more.
Hello everyone. So today I would be talking about the key business requirements which are associated with our project. Number one would be a user may have multiple daily logs for food and exercise, which means each user can track their meals and workouts every day. To give you guys an example, if a user eats breakfast, lunch, and dinner and also goes for a jog on the same day, each of these can be logged separately. This helps users and experts, which are the trainers or the nutritionists, see and track daily habits and adjust the user's plans accordingly. Secondly, each appointment involves one user and one trainer and or nutritionist. When a user books an appointment, it's always a one-on-one session, either with a trainer or a nutritionist. This makes the session personalized and more focused, helping the expert provide better advice and insights based on the user's goals and history. Thirdly, users can receive multiple reminders based on their preferences. Having said this, users can set reminders for different things like drinking water, be it sleeping on time, eating their meals, or even exercising. These reminders are totally customizable, so the user has the flexibility to choose what they want to be reminded about and the frequency of these reminders. Coming to the fourth point, progress reports are generated per user based on important health metrics such as BMI, weight, calories burned, or even consumed. So these reports help our users see how far they have come, and it also keeps them motivated in achieving their goals. The next point would be rewards. Rewards are granted based on completed activities or the goals that they have achieved. This is a strategy to keep the users engaged, which where the system gives rewards when they finish certain activities or establish certain goals. For example, like completing 10 workouts or hitting a weight goal. Uh, Sorry. So, 10 workouts or hitting a weight goal, then a reward will be given to a user. These rewards can be badges, points, or discounts, or and the ultimate goal is to encourage them to stay active on the app. Lastly, feedback is linked to specific appointments. After a user finishes a session with a trainer or a nutritionist, they can give feedback. This feedback is directly tied to that specific appointment, helping the staff improve more and making sure that users feel heard and supported. In this slide, we would talk about some business rules which involve some user-centric business rules as well as relationships. These rules define how users interact with different features and entities within the app, such as nutrition plans, exercise routines, appointments, rewards, and even progress tracking. By clearly defining the relationship between users and these features, the system ensures a seamless, personalized, and an organized user experience. This structured framework also supports data integrity and user accountability, and it also provides a tailored wellness journey for every individual. For example, we can go through a couple of user-centric rules, like each user may have zero or more than one nutrition plan based on the goals. Similarly, every user can have more than zero or more food logs, which, for example, a user will be consuming multiple meals in a day, like breakfast, lunch, and dinner. A user may have a zero or more exercise plan, again, which will depend on the goal. And similarly, there are all the business rules, user-centric business rules, and their relationships. Next, next, Sayan would walk you guys through the entity relationships and the SQL code.
Our database can be broadly divided into two parts, one related to food intake and nutrition records, and the other to exercise report. The rest of the database is about managing these two important parts comprehensively, and so I will explain them one by one. First, the user entity is the heart of our system. Everything in the app revolves around the user. User entity stores all personal information, including password for the app and user goals. The food entity stores all types of foods that user might plan and log. It has columns for the unit and calories per unit. The nutrition plan and food log tables contain the food ID and quantity, which is how many units. The system recalculates the total calories. So this allows us to track how many calories the user has consumed and help us understand their diet habits. Now let's move to the exercise part. Next. The exercise entity includes all types of workouts and physical activities. It stores details like intensity level, duration, and the corresponding calorie burned. The relationship between exercise and user is managed by the exercise plan. This records what exercise the user will do, in what order, and how many repetitions. And we simply added a complete YN column to indicate whether the plan has been completed or not. Next, let's look at the user appointment management section. This part is for scheduling personal training and nutritional counseling appointments. The trainer nutritionist table stores information about the staff, such as their age, gender, and years of experience. Based on this information, users can select the step that best suits their needs. And the appointment table is set up so that each user can only book an appointment with a staff member at a specific time, ensuring no double booking. The feedback column is for a specific appointment, so it can be used to evaluate the step and check the user preferences. Next, finally, let's look at the progress report section of our ERD. This table stores the user's health progress. It tracks data like weight, BMI, and sleep hours. And the earned calories and consumed calories for a specific date are extracted from the food log and exercise plan tables. So with this, the user can get a daily overview of their health status, see how close they are to reaching their goals, and gain insights on what needs to be adjusted. Next. So the remaining entities are related to additional services like group activity management, app reminder, and a reward program to encourage users. So I just skipped the detailed explain of them. So next, here I will cover the key points of the data implementation code. aside from the normal creation and insertion. So first, we use the column level track constraint for simple categories within a column. And we also use the table level tracks for business rules. For example, a user must have a unique username and email address. So we use the trigger for this. So because a function can't reference the column in the same table being inserted. And next, we apply the column data encryption to personal information, such as password, email, and phone numbers. And using the encrypt by passphrase function, which is the built-in function in MS SQL Server. And we also created a function for column value computation. For example, in the food table, we store the calories per unit, and in the food log table, we store the quantity. So by multiplying these values, we can calculate the total calories consumed. And we have a view that tracks the user's net calories at a specific point of time. This helps guide the next steps, such as determining if more exercise is needed to burn calories or if the nutrition intake is insufficient. And lastly, next, we extended the progress report table. We calculate the user's current age based on their birth date from the user table, and we classify the BMI status from numerical data into categories for a quick overview. And now the Isaac will explain about our visualization and insights.
Thank you, Sayan. So, to gain a better understanding of our health and fitness management system and gain a better visualization and actionable insights, we provided sample data into the entities that were mentioned by Sayan. So, for example, we will give sample input for the user, the food that he consumed, the calorie that he burnt, and the calorie that he intook to be able to personalize the workouts and, for example, the food recommendations that we can provide for a particular user. So what we did was we gave the sample input, exported that sample input in the form of a CSV file, and we imported it into the Power BI tool, for which in which we used several charts, like for example the bar plot, the histograms, and pie charts to gain a better understanding of the net calories, the user weight distribution across BMI, and also the distribution of average BMI for individual age groups, and also the BMI distribution by user. So to begin with, here you can see in the first chart that we have, the plot illustrates users' net calories calculated as calories consumed minus calories burnt. And as you can see, the dark blue bars indicate the calories consumed, while the light blue bars represent the calories burnt, and the orange lines track the net calories for the users. And if you see, there is a dip in the orange line, which means that the user is in a calorie deficit. And if it is going top, it shows that the person is gaining weight or is in a calorie surplus. And the next visualization we have here is the user weight distribution across which BMI. This visualization supports the development of our fitness management application by illustrating how user weight data varies across different BMI categories. So here we have the normal, overweight, and obese categories. It uses key metrics from user data, for example, are maximum weight, minimum weight, and average weight aggregated for each BMI category. So by analyzing these weight distributions, our app can personalize fitness recommendations based on a user's BMI status and identify key trends and outliers, set realistic fitness goals like targeted average weight ranges seen in a normal category, and also track progress by comparing individual weight matrices with category benchmarks. And the next visualization we have here is our distribution of average BMI by age group. So this horizontal bar chart helps us visualize the body mass index across 4 age groups, like for example 38 to 48, 42, 43 to 47, 48 to 52 age groups, and so on. As you can see, there is a peak at the age group of 48 to 52 with 28.88 BMI, and there is a slight drop seen in the age group of 53 to 57 age group. So all this information is an actionable insight that can help our fitness management system tailor age-specific wellness strategies and identify high-risk age segments and offer targeted interventions to manage BMI effectively. And last but not the least, we have our pie chart. The pie chart displays the distribution of users across 3 BMI categories: normal, overweight, and obese. These uh, categories, based on these categories, the height and weight data, the majority of users, for example, 57% here fall under the normal category, following by 33% fall in the overweight range, and 9% categorized as obese. So this visualization helps our fitness management system identify the overall health profile of the users and enables us to personalize the fitness plans focused on at-risk groups and also track the BMI improvements over time. So the next will be a short demo of how our dashboard, our system will look like, and will be presented by Mohit.
Hello everyone, I will be giving a demo for our project. So we are using the Streamlit Python web app that connects to an SQL Server database and displays personalized fitness data for a user. And Pandas is used to handle tabular data and display it. So we are doing this because it makes it easier for the user trainers and nutritionists to be updated with the user's daily progress, which will help them understand the user better. And it is more easy for them to manage the approach they will be using for the user. We have total of 10 users, but for the demo, we will be checking for Ted Mosby. Once we insert his name and email, we get all the details associated with him, where you can see after logging in, he can track many entities such as food log, calorie balance, trainer or nutritionist appointments, progress reports, rewards, and activities. So this is useful because users can just log in and get insights on what they ate, how many calories they burned or consumed, their appointment information, rewards they earn. So by doing this, the users and their trainers or nutritionists can stay updated with the daily habits which would help them towards improving the user. So for example, if a user wants to lose weight, the trainer and nutritionist will come together to make sure the user burns more calories than consumed. So where the trainer would give the user HIT workouts, which are high intensity workouts that would burn more amount of calories than the usual workouts, and the nutritionist will make sure that the calories consumed in the food log should be less than the daily calories burned. So with the daily tracking of the data, they can schedule appointments with user to help them know that they are doing it right or wrong. So now you can see in the food log that Ted Mosby has had burger for lunch, and you can see how much calories is that. So as previously mentioned by Soyong, it says quantity. So if it's one quantity, it will be 550 calories. If it would have been two, it would have been 1100 calories. And for calorie balance also, you can see the total calories consumed, calories burned, and the net calories, which is the difference between them. And in the appointments table, you can see the upcoming appointments with trainer or nutritionist, but he currently has a appointment with Ranjit Singh, who is the trainer. So now I would ask Ashish to conclude our project.
Yeah. Hi, I'm Jenny from Group
Hi,
3.
hi, Chenny.
One sec.
I'm so sorry. Before we move on to the questions, I would just like to wrap up by
Oh, sorry for that.
I'm really sorry. I'm really sorry for that.
No worries,
So
it's my bad.
yep. So I mean, we would like to wrap up by saying that just a message for everyone that health is the most important part of our lives, and that is what inspired us to work on this project. Our goal was to focus on key factors that affect people's health and provide useful insights to help users improve their well-being. We applied several concepts from this course, such as creating ERDs to plan our database, adding check constraints, and calculated columns for data accuracy. We also implemented data encryption to protect personal information. These techniques helped us build a system that is both effective and even secure. Looking ahead, we hope to develop this into a mobile application so users can easily track and manage their health. We also aim to include much important features like glucose and blood pressure tracking, which are important health matrices, which would also help us recommend meals and exercising by exploring some AI techniques. Uh, and I would also like to thank Professor Simon because this project gave us a great opportunity to apply what we learned in this course to a real world idea that can truly make a difference. And lastly, I would like to thank everyone for your patience and listening to our presentation. And yes, if you guys have any questions, we would love to answer them.
Yeah, sorry for the interruption. I'm Chenny from Team 3, and we really like your UI design, and the presentation is structured and informative. And I do have a quick one about the table design. I noticed that the food part has two distinct tables about plan and log, but the exercise part has only on exercise plan. So may I ask, why do you design like it?
Thank you for your comment. And yeah, this is a good question because that was what we considered carefully. So, because the food plan and what they actually eat can very differ in real life, but the exercise plan can be more straightforward because the types of exercise are more limited to be provided. So yeah, we designed these two parts are differently, like as you can see.
Yeah, that makes sense. Thanks
Yeah,
for detailed answer.
thank you.
Hi, I'm Yang from the Team 3, and I think your demo is really cool, but I still have small questions. Yeah, what is difference between the column feedback in exercise plan and the feedbacks tables? I'm really curious about that. Thank you.
Hi, Yang. I'm Bebe from Team 4. Thank you for your question. And I think it is a really good question. Actually, we have considered this when we design our ERD, when we define our entities and attributes. We are thinking that a feedback column in appointment is a personal record about the reflection of trainer and nutritionist, and it can be used for service improvements and evaluation. However, the feedback table is for the public world on website or the fitness management company that the customers gives. Is that make sense?
Oh yeah, that makes sense. Thank you for explaining.
Thank you.
Do we have any other questions? If not, again, I would like to thank everyone.
Yeah, great. Great work and presentation from Team 4. Team 4, your demo, left demo was very interesting. Could you share more details about how you develop your live demo?
Yes, sir. Sure. So, I would request Mohit and Isaac to share some insights on how we created the demo.
Yes.
So,
So for the
yeah,
okay,
Mohit, do you want me to explain about the code, or you want me to?
okay, you go ahead, then I'll continue.
So, to begin with, sir, for the UI, we created a modular UI using a Python framework called Streamlit, and we used Pandas data frame along with it. It is basically we initiated a connection from the UI to the MySQL server. We defined our server name, database name, the password, and user ID. With that, we gave the like our UI design, like for example, find your fitness summary and all our input columns as well in the Streamlit Python library. So, and after that, for the backend part, once the connection is made, we made sure the input that is passed in our input box is being passed to the MySQL server. So the query that we enter here will be passed to the MySQL server, and we will fetch that particular information from our tables and display it in front of the UI. So this is a very simple demo, but to extend it, we would like to go on with a mobile application which is more robust for, let's say, a lot of 100 users or more than 500 users.
Yeah, it's very interesting. So when you said MySQL server, did you mean our class server?
Yes,
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 sir.
yes, sir.
Okay,
Yes, sir.
excellent. Yeah, very, very interesting work. And thank you for
Yes, sir.
the detailed
So
walkthrough. Yeah,
here, so when we are entering the name, we are tracing it with the user ID and then displaying all the results.
excellent, excellent work. And a very interesting live demo.
Yeah.
Okay. Thank you, sir.
Okay, any other question or comment for Team 4? Okay, thank you again for Team 4 and the questions. This is the end of our project presentation. I was impressed with your accomplishments in DAMG Sector 10. Kudos to everyone.